Hello, welcome to the Ankara Yıldırım Beyazıt University Soil Mechanics Laboratory. This video will demonstrate how to conduct a liquid limit test using the Casagrande liquid limit device. The plastic limit test will also be conducted. The relevant ASTM standard is ASTM D 4318-05, liquid limit, plastic limit, and plasticity index of soils. The purpose of this test is to determine the plastic limit, the liquid limit, and plasticity index of a given soil. These parameters are used to determine the engineering classification of soils. They are also used individually or together with other parameters to estimate various engineering parameters such as compressibility, permeability, and shear strength. The soil to be used in the Atterberg limit tests is the fraction of the soil that passes the 425 micrometer sieve, or the number 40 sieve. About 150 to 200 grams are required to run the test. The method of quartering or splitting may be used to reduce the sample size if needed. The equipment needed for preparation of the soil is the number 40 sieve, a mortar and pestle with rubber tip. This one does not have a rubber tip. A spatula and a mixing bowl. Equipment needed to conduct the liquid limit test are a liquid limit device or Casagrande apparatus, a flat grooving tool, a porcelain dish and spatula, a squeeze bottle with demineralized water, several moisture cans, and an oven for water content determination. For the plastic limit test, a flat glass plate, several moisture cans with lids, and a 3 millimeter metal bar for gauging the thread thickness are needed. The test can be performed using the following steps. According to ASTM, there are two methods of soil preparation, the wet method and the dry method. The dry method will be used today. In the dry preparation method, the soil is air-dried or oven-dried at a temperature not exceeding 60 degrees C until the soil clods will pulverize readily. Pulverize the material in a mortar with a rubber-tipped pestle or some other means that does not cause breakage of individual particles. Care should be taken such that coarse particles, such as shells, are not crushed but are removed by hand and discarded. You may also remove any organic material, such as plant roots and weeds. The material should be separated on the number 40 sieve shown. The material retained on the sieve should be pulverized until all retained material consists of individual particles rather than aggregated clumps. You need about 300 grams or 150 to 200 grams of minus number 40 sieve material to run the test. Once you have obtained enough of this material, pour it into a mixing bowl and wet it with demineralized water from a water bottle. Mix it thoroughly with a spatula until it appears homogeneous and the surface looks creamy. You should not put too much water that the soil goes into the liquid limit state. You should let the clay stand for 30 minutes or more at least. If the clay is very plastic, it is preferable to have done this procedure 16 hours prior to running the test. In other words, you should prepare the soil a day in advance so that the clay, if it is very plastic, has time to hydrate. Determine the tare weights of 4 water content containers and record it on your data sheet. The Casagrande apparatus can easily be knocked out of calibration. So before you begin the test, you should inspect the Casagrande device and the grooving tool to check that they are in good working order and are in calibration. The height of drop of the cup should be within 10 plus minus 0.2 millimeters. The back end of the grooving tool has a plastic block that is exactly 10 millimeters high. This end may be used as a gauge block to check the height of fall of the brass bowl. Insert the gauge block at the point of contact between the brass cup and the hard rubber base. It should be in contact with both. Check the drop height by turning the crank several times. At the correct height, a faint clicking sound can be heard, but the cup will not rise above the gauge block. You may need to use a screwdriver to make the adjustments needed. Note that the end of the grooving tool has a length of 12.7 millimeters. Of the gap that must be closed when you are running the test. You can use this end of the grooving tool to help you determine when to stop the test. The third step is performing the test. Before you fill the cup, you might want to practice turning the Casagrande handle at a rate of 2 revolutions per second. If the apparatus you are using has a counter attached, make sure you reset it back to 0 after you practice. Note that the end of the grooving tool has a length of 12.7 millimeters. This is equal to the length of the gap that must close when you are running the test. You can use this end of the grooving tool to help you determine when to stop the test. Determine the tare weight of 4 moisture cans. Record their identification numbers and tare weights into your data sheet. Then, use a metal spatula to fill the cup with a pat of soil. It is important not to have any trapped air bubbles inside the soil pat. Hence, it may be useful to build the pat in layers using slow, smooth strokes beginning at the center and moving to the edges. The depth of the pat at the center should be about 8 millimeters. The surface of the pat should be smooth and preferably horizontal. Cut a groove along the center line of the brass cup. When cutting the groove, hold the grooving tool against the surface of the cup and draw an arc such that the tool remains perpendicular to the cup at all times. The shoulder of the grooving tool should just scrape the surface of the pat. If the shoulders do not touch the soil pat, it means that the depth of the pat is not sufficient. In that case, you should empty the cup and refill with a larger amount of soil. In soils where a groove cannot be made in one stroke without tearing the soil, cut the groove with several strokes of the grooving tool. Alternatively, cut the groove to slightly less than required dimensions with a spatula and use the grooving tool to bring the groove to final dimensions. Exercise extreme care to prevent sliding of the soil pat relative to the surface of the cup. Once you have completed the test, make sure to put all of the water content samples into the oven to dry. They should remain there at least several hours or overnight to dry completely. Once they are dry, weigh them and determine the water contents for each test. Record this on your data sheet. On a semi-log plot, plot the number of blows versus water content. Draw a best fit line through all of the data points. Using this line, determine the water content corresponding to 25 blows. This is the liquid limit of the soil. Since it may be difficult to plot on a semi-logarithmic graph, you may use Excel to help you. If you select the logarithmic option for the x-axis and plot your data into Excel, your graph will be correctly plotted.